5.2, one-to-one functions and inverse functions. Some of this is missing. Okay, so one-to-one functions. One-to-one functions mean nothing repeats. A function is there can be no repeated x values. There cannot be an x used for two different y values. A one-to-one function means nothing can repeat. No x's, no y's. No repeats at all. So they have to pass what is called a horizontal line test to be one-to-one. You are looking for no repeats. So you, instead of checking it vertically, you now check it horizontally. If it passes a horizontal line test, it is one-to-one. So you have a couple of examples here of one-to-one functions. Now, let's get into inverse functions. I am not going to redo example 1. It is really easy. It's just a basic look at what an inverse is to get your memory going from Math 3. You did do inverse functions in Math 3. You start looking at them in Module 1. And you continue to kind of see them in Module 2 a little bit with the exponentials and the logs. So we just got to draw that information back up. So find the inverse of each one-to-one function. State the domain of the inverse function. So really big here I have highlighted. When you are finding the inverse, you are switching the x and y values. So if I have, here I have a set of ordered pairs. Instead of 3, 4, when I find the inverse, it becomes 4, 3. I am switching x and y all the way through. And then state the domain. We need to remember the domain is the x values. So specifically you state this as just the specific ones. Do not say it's from, oh, my smallest number is -1 and my largest number is 7. Do not put it's from -1 to 7. I will not even give you partial credit for that. When you tell me -1 is 7, you are including everything between -1 to 7, including all decimals and fractions that exist between those two numbers. And that is not the case. It is just these numbers specifically. So your domain is going to be x such that x only equals -1, 0, 4, and 7. So you do need to make sure you write those out. I'm okay if you write it this way, but this is proper set notation for your domain. All right, example 2, moving right along here. Verify that the functions are inverses. Give any values of x that need to be excluded. So verifying that functions are inverses, we did that in the last section in 5.1, where it said show that you got x and x. When you plug those functions into each other, that means they're inverses. So when I plug g into f, I should get x. When I plug f into g, I should get x. So I wrote this a couple different ways to help you guys through this. So let me show you the work here. So I'm going to start with, I did not mean to erase that part of the x. I'll just leave that ugly thing there. So I'm going to start with f of g of x. That means g goes into f. So this one goes right there into x. So 3, instead of x, I put 1/3, x minus 4, then I have plus 4. Now I know that this looks complicated. It is not complicated. First, you multiply these two numbers together. 3 times 1/3, the 3's cancel. I am left with 1 times x minus 1. So I do not distribute the 3 to everything. You distribute it to just one of those terms because 1/3 is being multiplied to x minus 4. So when you multiply it to the 1/3, it eventually gets multiplied to the x minus 4. Just so happens that the 3's canceled. And then distribute the 1, you just get x minus 4 plus 4. Those are gone, and I'm left with x. Now I'm going to work through g of f of x. So here f is going to go into g. So f goes into g. So 1/3, and instead of x, I put 3x plus 4, and then I have minus 4. Well, the 4's are going to cancel, so I have 1/3 times 3x. 3's cancel, and I'm left with x. Now, it says, give any values of x that need to be excluded. Please do not forget, this has to do with your domain. And the things that you need to look for: fractions with x in the denominator and square roots. If you have that, then you need to figure it out. Look back at your notes from 5.1 about the fractions and the square roots. Here I have neither, so there are no excluded values. This is negative infinity to infinity for your domain. Moving along. Example 3. The graph of a one-to-one function is given, which means it passes the vertical line test. Draw the graph of the inverse function. So the inverse function, please do not forget, we switch x and y. So if I have the point 3, 8, that is going to become 8, 3, and so on and so forth. 2, 5 becomes 5, 2. Negative 1, 4 is going to become 4, negative 1. Notice how I am not changing the signs. Negative 2, 1 becomes 1, negative 2. I'm just switching their spot. That's all I'm doing. So now I'm going to go ahead and plot those points. So let me put the grid back up. So 3, 8 became 8, 3. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. And then I have 5, 2. 1, 2, 3, 4, 5, 2. 4, negative 1. And then 1, negative 2. You might have a hard time figuring out how to connect these points. It's not that bad. Connect them, connect them, connect them. And I hope you recognize something here. There is some symmetry here. Take a second to think about where these two figures are symmetric to each other. I hope you are thinking of the line y equals x. These two functions are symmetric over this line right here. This is the line y equals x. All inverse functions are symmetric to the line y equals x. And if you turn your paper sideways, I'm turning my tablet sideways right now so I can look at that, and it's perfect. I can see that it is symmetric to the line y equals x. And it's not that bad when you guys are drawing that, but the line y equals x will help you. Okay, example 4. Think how many we have here? Just 5? So we're almost done, you guys. Hang in there. So find the inverse. So in the last example, to find the inverse, we just switched x and y. Then we have to state the domain and the range of each and then graph them. I'm not going to do the graphing for you. You guys can graph them. This is a line, and the inverse is going to be a line. You can graph them. I am not going to. So to find the inverse, this is y equals 4x plus 2. The first thing I'm going to do is I'm going to switch x and y. So x equals 4y plus 2. The second thing I'm going to do is I now have to solve for y. So I have to subtract 2. X minus 2 equals 4y. This is kind of weird for me, the y being on that side. So I'm going to put 4y equals x minus 2. Then I'm going to divide everything by 4. So y equals 1/4 x minus 1/2. There's your inverse. Now to identify this as being the inverse, we use function notation with f to the negative 1 of x. That means inverse. And it's 1/4 x minus 1/2. So I'm going to make a note back here for you. F to the negative 1 of x is how you end up writing your function notation for inverse. Please make sure you remember that. So there's my inverse. Then it says state the domain and the range. Well, I have a note here. Once I find the domain of f, I have the range of the inverse. Once I have the domain of the inverse, I have the range of f. That might sound a little confusing to you. When I am looking at f of x is 4x plus 2. This is a line, which means your domain is negative infinity to infinity. When I look at the inverse function, 1/4 x. Oh, that's also a line, which means this domain is negative infinity to infinity. Domains you do need to be able to find without graphing. Now, to find the range, this is what I'm talking about here. The domain of f is the range of the inverse function. So I have the domain of f, which means it's the range of my inverse. And then the domain of the inverse is the range of the original function. So down here, my range becomes negative infinity to infinity. And again, these are lines, so you should know that. But the idea that they're switching, don't forget x and y switch. This is my x values, which become the y values. These are my x values. They become the y values. So, and vice versa. When I have my x, I have my y, you switch them. That is now your x, that is now your y. So, easiest thing to do, find both domains and then switch them for your range. Very easy stuff. But you got to practice it. Don't just be like, oh yeah, it's easy, I'll remember it. You do need to practice. So we're going to practice this one more time. And this is not a line. This is a rational function. Because it's rational, I know it's rational because it has an x in the denominator. So I'm going to work on my domain first. My domain for f of x. Actually, yeah, I'm going to put that. F of x domain. Before I even find the inverse, your denominator can't be 0. So 3x minus 1 cannot equal 0. Add 1. 3x equals 1. X equals 1/3. So my domain is x such that x cannot equal 1/3. So I'm going to leave that for now, and I'm going to go back and find the inverse so I can find the domain of the inverse function. So let's remember the steps. The first step is I need to switch x and y. So this is y equals 2x over 3x minus 1. So switching them, x equals 2y over 3y minus 1. I have to switch it for every single x. So I cross multiply. So I multiply across. I get x times 3y minus 1 equals 2y. So I have a little bit of work ahead of me right now. I multiply 3xy minus x equals 2y. I need to get my y's together. That's what I'm solving for. Y's must be together. So I'm going to move the x over here, and I'm going to move the 2y over here, which is going to give me 3xy minus 2y equals x. Now I need to recognize both of those have a y. So I can factor a y out. 3x minus 2 equals x. Now I can divide by 3x minus 2. So y equals x over 3x minus 2. So my inverse is x over 3x minus 2. I do expect you to be able to work through a problem like that. And if that is something you're struggling with, you might need to come in and get some help with your factoring and maybe your procedural stuff with solving for a variable. Maybe you need to watch it again. Maybe you just need more practice. If you're still struggling after all that, please make sure you come in and get some help. So now, there's my f of x. To find my domain of f inverse of x, to find my domain of f inverse of x, I have to look at the denominator. The denominator cannot equal 0. So, I'm going to come over here, and I'm going to use red, f inverse of x, the domain. So the 3x, what was it? 3x minus 2 cannot equal 0. So if I move the 2, I add the 2, 3x equals 2, x equals 2/3. So this is x such that x cannot equal 2/3. So I have the domain for each. Now you're really going to get to see what is meant by switching. So now I need to find the range. We need to remember the domain of f of x becomes the range of the inverse, and the domain of the inverse becomes the range of f of x because x and y switch. The domain is x, it becomes y for the other function, for its inverse. So my range here will be y such that y cannot equal 2/3. And then the range over here will be y such that y cannot equal 1/3. So I switch them. We have to remember that they switch. Please make sure you remember that. Your x and your y switch. If you need to watch it again, watch it again. Whatever questions you have, make sure you come in and ask tomorrow. We will be going over this in class. Hopefully it will make more sense to you. We'll spend a little bit more time on it. And if you get it, great. You can start your classwork when you get into class tomorrow. Otherwise, hopefully your questions will be answered then. See you tomorrow.